Well, I was first quite pleased to have this early slot, to get this ordeal over with and relax and enjoy the rest of the day. That was before I realized we would be speaking just after Mike Williams. My name is Dominic Williams.
I'm Fabrice Noisson.
And we're going to be talking about some of the things we've learned from developing high availability systems in Erlang. We're from Extreme Forge. Extreme Forge is a team of experienced software developers. We design, craft, maintain reliable internet and telecom systems. We've chosen Erlang, and for once I don't have to explain why. We also use extreme programming, which is a set of simple and effective work practices. And with all these help us to build a close, trusting relationship with our customers. And our goal is to deliver usable new features each week with such high quality that support is free.
We have been developing for 15 years, mostly critical systems for telecom company, wireless and web development. We wear different hats. We do a lot of development, but also we manage team and bring our expertise in critical systems. And we also provide training in Erlang and extreme programming.
So over the years, some of the systems we've worked on, these very critical high availability systems, which have given us some of the experience we want to share this morning, are these ones. So the Silicium Myriad USSD gateway. So USSD is like the telnet of SMS. It's a text-based telecom interface with a connected session. So you can do interactive stuff. It's like a text-based kind of WAP. And this system was sold to over 30 telecom operators around the world. And some of them had very large user bases, over 20 million users. On the highest capacity systems, we were handling up to 5,000 messages per second. And despite having to have monthly upgrades with new features and improvements, we could keep these systems with an uptime of 99.99%. We also worked on the initial architecture of the MIG SMS gateway, which was presented at the factory a couple of years ago. And on web development, the coreprama.com website is entirely developed in Erlang. And more recently, we've worked at a French telecom operator in their call center, redoing in Erlang a web service, a critical web service, which is in Java, and for which they had difficulties with upgrades. So they're experimenting with Erlang for its hot upgrade capacity.
So, this is the first example. I think you all know that there is two ways to remove a warning for unusable variables. The first way is to use anonymous variables with an underscore, and the other way is to prefix a variable with an underscore. Thus, this is two different things. In this example, if you want this code in one shot, we probably do not do this error, but we bound a variable underscore args, and later on, the underscore args is used in another pattern. And in our career, we saw so much bugs come from this behavior. We bound the underscore variable in our code. And we propose to help the developer, we propose the fact to the compiler to warn an additional warning when the underscore variable is used.
Okay, so that was just a kind of to get started on something simple. Now, another thing we've we noticed is there's something which is often necessary, which is to perform a regular action, especially when a gen server is idle. And we've seen many designs to try and achieve this, which are overly complicated. And so we've realized that there's a little known feature in gen server which lots of people don't know about, which is the timeout. In handle call and in handle info, in the tuple that you return from those functions, you can optionally provide a timeout. And what this timeout does is that the gen server, if nothing happens before the timeout expires, then it'll send you a timeout with the handle info. So you can do this in handle call or handle cast, and it's very useful for lots of different kind of things. So in this example, we've used the timeout to stop the process. So this could be used for a gen server which you want to stop. If it doesn't get used after a while, you can just automatically stop it. It's useful for lots of other things, like keeping a connection alive, which can save time once you get a message and you want to use the connection. Or you can use it to close a shared resource when it's not being used anymore. Or you can use it to re-register workers so they can register themselves, and if they stop being used for some reason, they say something must be wrong, I'm going to re-register myself so that I can get some work again. Okay, so after those just two kind of little coding tips, we're going to start talking a bit more specifically about some of the high availability stuff. So there's this thing in Erlang about letting it crash. And of course Erlang provides lots of powerful features to allow you to supervise processes when they crash and to restart them. And this is why the most elegant way to program in Erlang is not to write lots of detailed error handling code, and instead just write as if the code was going to work, and then you let it crash. And that's fine because there are lots of ways to keep the system running. But in a wider sense, if you're writing a high availability system, there are lots of things that you have to be very careful about and that you don't want to let crash. The VM, for example, can crash, and although there is a heartbeat system to get it restarted, when the VM crashes, most systems will go into a pretty disturbed state. The operating system as well, things can go wrong there. You can run out of disk space or file descriptors. So in the rest of the talk, we're going to see some of the things that we recommend in order to avoid these kinds of risks.
So let's crash the VM. So the atom in Erlang, it's an elegant way to programming, but you all know the atom, tabular atom is not garbage collected, and there is a limit. And if you reach the limit, the VM crash, and you can proceed. And this is a small example. We crash the VM in less than 1 minute.
So you see there that the atom table's maximum is by default about 1 million. You can change that default, but it's still limited. Now, if you're just writing atoms by hand in your code, and that's what you should be doing, that's fine. You're very unlikely to reach that limit. So the danger comes from the atoms that can be created in lots of other ways than just when you're actually typing them in your code. And some of these ways are if you're using generated code, for example with the SN1 compiler or YEC generation. If you're reading files with data, configuration data or templates, and if you convert some of the stuff you're reading into atoms, then you have to be careful if those files can come from increasing number of sources. Parsing also, if you're parsing XML or parsing JSON, most libraries generate atoms from what they parse. Now that's okay if you're just using, a limited number of XML schemas and things, but if you're writing an XML accelerator, or if you're writing a compile farm or something which is going to keep accepting more and more stuff and generating atoms from it, then at some point you'll run out of atoms. So our recommendation is just not to use list to atom. There is another, they introduced after a while another BIF, which is list to existing atom, and that's what you should be using to convert stuff from the outside, from files or messages, into atoms which you already have in your code for some other reason. But don't use list to atom to convert atoms from just without any control. Okay, so on another topic, it's important to another way to crash the VM is to run out of memory. And this is quite ugly. You don't get, it's not something you can handle in your code. There's no exception you can catch. There's no way to recover. The VM will just keep grabbing memory until it runs out, and the VM will crash. So it's important to avoid this. And also, just even before it crashes, if you just keep having lots of processes, then the system will become overloaded, and then lots of other things can start going wrong because you'll have increased latency in various messages and so on. So ugly things will start happening. So use a fixed number of processes. Obviously in your design you probably have some important gen servers or gen events or whatever, and they're unique. The problem comes from when you spawn processes to handle high volumes of stuff like incoming connections, or if you spawn processes to perform work in parallel. So that's where you have to also be careful and use a fixed number of processes. Now, there's a frequently seen problem, something we've seen quite often, is these processes that get spawned to perform work. There's a tendency to reuse them. This might come from the concept of a process pool, and with thread pools the idea is that you have a fixed number of threads, and so if with Erlang processes you have a fixed number of processes and you keep recycling them and reusing them and giving them new work, then ugly things can start happening, and we've seen a number of bugs with this, and we've seen systems where over a period of a couple of months the memory just kept going up. It looked like a memory leak. And after investigating this, we realized that it wasn't actually a memory leak. It's just that by recycling worker processes, the garbage collection was just, kind of, I'm not exactly sure why, but it was just using more and more memory, as though it kind of remembered that it needed memory in the past, and it just kept, it was allocating bigger blocks of memory than it really needed to. And this was solved by just not reusing processes, spawning and terminating processes in Erlang is very cheap, so always spawn fresh processes and use them once and throw them away and start new ones for every job. Lots of other things apart from the memory allocation. You can have unpurged messages in the queues. If the code is using the process dictionary, this is going to get polluted from one job to the next, so always throw them out and start with a fresh process. So if you think about those two previous recommendations, the one about using a fixed number of processes and the one about spawning fresh processes all the time, this leads to a design pattern that we now use very, very often in high availability systems in order to control the load on the system, which is to have a queue of jobs, and then to spawn fresh worker processes, and they come and ask the queue for the next job. So it's not exactly like a process pool, it's really a job queue, and then new workers come and ask for jobs, but you need to control the number of those workers. Put an upper bound on the number of workers that you create. The details of how you implement this, apart from having the queue and apart from keeping track of how many processes you've created, will depend on the requirements for those worker processes. In some systems it's acceptable for a job to crash and then just, in that case, you've lost maybe a message or you've lost a connection and it's not serious. So in that case, the simplest thing is just to use as a plain Erlang spawn and give it the job, and then if that crashes, too bad. If you need to supervise those kind of processes because they might have a session which needs to be kept, they might have state which you need to keep, or because it's unacceptable for even for one request not to be answered, then you probably need to use simple one-for-one supervised processes. And the nice thing about this design with a job queue and then a fixed number of processes that come and ask for jobs is that it's very easy to load balance if you need to, if you're using a multi-node cluster. Now another thing which is might be a bit controversial is that we strongly feel you should avoid records as much as possible. Records can be, some people think they're a nice way to program, a bit like atoms, but they have problems, especially for hot code reloading. When you have different versions of records in your code, those are incompatible, so a lot of care needs to be taken when you do the hot code reloading and you have a new version of a record. Now, if you're using GenServer, GenServer provides ways to do this, but it is more complicated, it's error prone. Every time you upgrade the code, you have to write specific code to handle the migration from one version of the record to the next. And so in practice, we've seen that even if you get it right, sometimes you're going to get it wrong other times. And so we feel it's much, in general, try to use dicts or all dicts or prop lists, which are much more flexible. They're compatible from, you can add new items in those dictionaries and the old versions will still work. So they're much easier to hot up for hot upgrades.
In a whole day, we have configuration files because it's quite really difficult to upgrade code online. But today with Erlang, it's not true anymore, and we have to change way of programming and to put configuration files in the code. Because if you want to have a fine upgrading system, the code and the data should follow the same direction strategy. And there is only one solution to achieve this. It's to put all your data in your Erlang code. And it's very important for swapping code.
Okay, and just to finish off, there are lots of other things which are important for high availability, which we don't have time to go into in this short talk. I will just mention them quickly. The main one certainly is that you really must have very serious performance and load testing and endurance testing. And this is a huge undertaking. If you really want a high availability system, you're going to need a specific platform which is pre-production, which is representative of a real platform, and on which you perform really serious stress and load testing. You want to use that platform also to test every upgrade. Erlang provides all this great stuff for hot upgrading, but every time you're writing a release upgrade script, you're writing a schema migration stuff for amnesia, or you're writing stuff to upgrade records. Every time it's a new upgrade, so you have to test it. You have to run load tests on your on your old version and upgrade it to make sure everything is still working. And you have to do that before you do it in production. Another thing we've seen quite often is people, maybe with the habits that come from other programming languages, using far too many, doing much too much logging, especially the debug info stuff. Logging in Erlang should really only be used for what your customer needs. The auditing, keeping track of history of what's happened in the system. But for all your debugging needs, there's much better stuff in Erlang, which is all the tracing facilities. So get familiar with those, the DBG module, or ET, or Observer. There are more and more tools now. and they're great, but get familiar with them. They're also, with great power comes great responsibility. They can be dangerous, but they're very precious tools if you're maintaining a high availability system. And it saves you overloading your system with endless debug messages in the logs. So we talked about, one of the limits, which was the atom table. There are some other system limits. We'll read the documentation, get familiar with those. Think about some of the operating system things like not filling up disk space. So, do log rotation. That can be done with there are libraries in Erlang that help you do that. You can also use stuff like log rotate under Linux. There are many ways of doing it, but lots of things to consider. And we'll just try to give you some of the most important best practices. And that's it. Do you have any questions? Yeah.
When you're building releases to your code, do you have any additional tooling you recommend, or do you do that by hand?
Yeah.
So you write your app ups manually, do you use Rebar to generate the upgrade packages, or do you use other scripts for that?
No, we haven't so far. We haven't done it with Rebar. Yeah, we've had our own systems, and we write the release upgrade scripts by hand. We have we generally automate especially all the testing and the testing of the upgrades, but not especially using Rebar. But it can be done with Rebar as well.
Do you have any idea about the performance hit if you stop using records for state and then move to prompt lists or tickets?
No, not really. I mean, I don't have any idea, but I think my feeling about that is that like most of these things, it usually doesn't matter, because the performance on that kind of thing the difference is going to be fairly small. If you do have some performance problem, like all this, just the usual recommendation, you should really be measuring that, profiling it, finding where your real problems are. If they happen to be in the dicts, then that might be a good reason to go back to records. But in 90% of the code, that's not going to be the case. There is one inconvenience, which is records can be nice. In some cases, they do simplify the code, especially when you're using the pattern matching on specific items of the record. So there is a kind of a potential, but you can actually learn different ways of programming, which are just as elegant. Using records is still okay if they're private to a module, so they're not included by other modules, and also preferably in pure functions, and that's not a problem in terms of hard code uploading. In a gen server state, or especially in public records, that really complicates the reloading.
If you have to ship things to a customer record, do you always build a release package to go upgrade, or do you have another system where you just send a module and just like that works?
Yeah, well, at Silicium on the USSD server, for years we didn't build releases at all. We actually even often just patched a single compiled module, and that was fine. One of the problems we would run into was exactly what we described about configuration data. We had lots of XML files that really had an impact on the behavior of the system. Because those were much harder to handle cleanly, so we did start using releases after a while. And there's a lot you can do without using releases in that, and it's okay. It's just that you're kind of working without the safety net. One of the nice things about releases is that you can roll back and come back to the previous version, and that works cleanly. Releases are, they are complicated. It's harder work, but you do have some advantages. For years we did a lot without them.
That's usually why I'm not using records in gen servers. It's very hard to have another field initially.
Yeah, that's right. I mean, there are facilities to do it, just like there are facilities to migrate an Asian schema. It's just that if every time you do an upgrade, you have to think carefully about getting it right. Then, over a few years of working with a high availability system, there are going to be times when you get it wrong, and that's going to bring your percentage of uptime down. We don't use any particular tools. It's just a whole other project of Erlang code that we write. The USSD server in particular was complicated because it was connected to about 10 or 15 external systems, so we had to write simulators for all of those. So it's really a big undertaking. We didn't use any particular tools for that, but Erlang is easy to spawn lots of clients that are simulators. So we really just wrote them. What's important is, the most complicated thing is really having an actual platform to do it. You need the hardware, you need to write a lot of code that does all the simulation and the testing and the measuring of that. But we didn't use any particular tools.
Next one. Yeah. You had experience using native interface to communicate with external languages, and would you recommend avoiding it? How would you recover from failure?
Yeah, we've had this. We've had experience with that. We use mostly with C systems. So the main recommendation for high availability systems is not to write LinkedIn drivers, or at least not until. So start by writing what's it called? Not the LinkedIn one, but just a port. Just start by writing a port, and then once the port has been working for a couple of years and you're pretty sure it's solid, then maybe if you really need the performance improvement, that can be converted into a LinkedIn driver. But LinkedIn drivers just increase the risk that you're going to crash your VMs. Okay, thanks very much.